Alright, so this video is the third part of the last two videos, which I've covered the multiple choice question of this question paper, grade 12 physics paper 1 2019. It was a November question paper, right? So now we are at a section of Newton's laws, which is question 2. So I'm going to do the whole of question 2 in this video. So I hope that you're going to be here with me until the end of the video and you're going to be enjoying the video as well. So let us get right into it. So it had said block P of mass 2 kgs or it had said block P of mass 2 kgs is connected to block Q of mass 3 kgs by a light inextensible spring. Both blocks are on a plane inclined, okay? They're on a plane inclined at an angle of 30 degrees to the horizontal. Block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees to the incline. Block P moves on a rough section AB of the incline, while block Q moves on a frictionless section BC of the incline. They're saying we should see the diagram below. So they've given us the diagram, and below the diagram they've written an average constant frictional force of 2.5 newtons acts on block P as it moves from A to B up the incline. So let me actually draw this diagram that I've given us, and then try to analyze the whole question here before we get into the bigger questions. Right, so let me draw the diagram because I think it's going to take me longer to draw the diagram while you're watching it. So let me just pause the video and then show you how the diagram looks. Alright, so this is the diagram that they've given us, and of course they've told us that AB is rough and BC is frictionless. Frictionless also means smooth. Right, so the fact that I said AB is rough, it means that it's going to be a frictional force, which I'm going to call kinetic frictional force, that is going to be acting on block P as it goes from A to B or as it goes through AB. And here there's not going to be any frictional force, so here we don't have any, so there's no kinetic frictional force, and here there's kinetic frictional force. Every time when there's a frictional force, we have to take note of the following. So it is possible that we might actually need to utilize the following formulas. The first one is Fk is equal to the coefficient of the kinetic frictional force multiplied by the normal force. All right, and of course the net force, which is the second law, is equal to the mass multiplied by the acceleration. The other formulas that we may need to take note of is the weight is equal to the mass multiplied by the gravitational acceleration. Right, the other one is the force applied, not really the force applied, the coefficient, is it a coefficient? No, the component, that's what I actually meant. The component of the horizontal component of the force applied is equal to the force applied multiplied by the cos of the angle, and the perpendicular or the vertical component of the force applied is equal to the force applied multiplied by the sine of the angle. We also have to take note of the following components of the weight. So the parallel component of the weight is equal to the weight, which is mg, then multiplied by the sine of the angle, which I'm just going to call it alpha, and the perpendicular component of the weight is equal to the weight multiplied by the cos of the same angle, alpha. So these two angles are different. The angle for the force for the components of the force applied is different from the angle of the components of the weight. Okay, so these are the formulas that are possible for us to actually utilize in calculation of anything at all in this scenario here, right? So you have to prepare ourselves for any question that is going to require us to utilize any of these formulas, right? So this is not really our full analysis because we have to take note of the following. So since this is on an incline, this is not on a horizontal surface, this is on an incline, then of course the weight is going to have the component. So that means of course we're going to need this component. And since the force is applied at an angle, it is not applied parallel to the surface. Remember that the surface is inclined. So the force is applied not parallel to the incline. It is applied at an angle. So the fact that the force applied is at an angle, we're going to have to break it down into its components. So that means definitely we're going to have to consider the components of both the force applied and the weight. All right. So we're going to be able to see them via the free body diagrams. So we're going to have to draw the free body diagram of P and Q. So let us do that before we even get into the questions. So we're also going to need to expect to draw the free body diagrams of both P and Q for us to be able to see the components of the force applied and the weight. Let us do that. So this is going to be the free body diagram of P. So which forces are going to be acting on P as it goes from A to B or across AB? So this is going to be the free body diagram of P. So the free body diagrams. Free body diagrams. What I'm doing right now is what I call analysis. We are not yet answering the questions, so please be patient. So this is the free body diagrams of P and Q. So of P, we're going to have, okay, P here, which we're going to represent with the dot. And then there's going to be a force that is going to be acting on P. and it's going to be acting perpendicular to the surface. We call that force the normal force. So we're going to have the normal force acting perpendicular to the surface. So since the surface is inclined, therefore the normal force is going to be at an 90-degree angle, that direction, which is northwest. So we're going to have the normal force acting in a northwest direction. So we're going to have the normal force right there acting in a northwest direction. And then of course we're going to have the tension between the P and the Q. So we're going to have the tension acting parallel to the surface. So we're going to have, or the incline. So we're going to have the tension. And of course we're going to have the weight. We're going to have the weight, which is the gravitational force. And because it is going through a B, which is rough, there's a frictional force there, then we're going to have to indicate that there's a frictional force as well. Right, so this is the free body diagram of P. The other people will have to include the components of weight, so you're also welcome to show them like this. So this is the perpendicular component of the gravitational force, and this is the parallel component of the gravitational force. Right, so this is W perpendicular and this W parallel. So W parallel always acts down the incline. This one always acts down the incline, and this one always acts perpendicular to the incline. Right, so that means with P, there are two forces that are acting in opposite direction of the motion of the two blocks. So the two blocks are pulled up, but there's two forces that are acting down. That means that there's two forces that are acting in the opposite direction of the motion of the system. So there is the frictional force that is acting down. There is also the W parallel, or the parallel component of the weight acting down. So there's two forces that are acting down against the tension that is acting up on the block P. So I hope that you are aware and understand this free body diagram of block P. Now let us draw the free body diagram of block Q. So how many forces are going to be acting on Q as it goes up? So we're going to represent it with the dot, of course. So the very same way we did with the block P, there's going to be a normal force acting at a 90-degree angle to the surface. So it is going to be acting in a northwest direction. So there's going to be a normal force, and there's going to be a force applied, right? So this force is applied not parallel to the surface or the incline. It is acting at an angle. So this is the incline. This is the incline here, but the force is applied at an angle to that incline. So we're going to be like, okay, this is the force applied. So we're going to indicate it by FA, meaning the force applied, right? And then of course we're going to have, okay, remember that this is the surface or the incline, right? So we're going to have, since there is no frictional force, there's not going to be any frictional force, but there is weight. So is weight. And of course this weight is going to have its components. So this weight is going to have its component because the surface is inclined. It is not a horizontal surface. So it's going to have the component. So we're going to have the parallel component acting down the incline, and the perpendicular component acting perpendicular to the surface, right? So this is going to be the free body diagram of block Q. But you should also remember that the force is applied at an angle, which is 25 degrees to the surface or the incline. That means we have to break it down into its component as well. So since it is acting up and to the right, that means the parallel component is acting to the right, and the perpendicular component is acting up. So that means Fy is acting up, and Fx is acting up the incline. So up by I mean like vertically up, okay? Right, so these are the components of the force applied. So they're acting those directions respectively. So these two are the free body diagrams of block P and Q respectively. Right, so we have actually done the full analysis by this. Now let us get into the questions. But remember that you also need to be aware to note the values that have already been given. So they've told us that the frictional force that block P is going to experience is, frictional force experienced by block P is 2.5 newtons. So we have to be aware of that. So this frictional force, we might actually need to substitute it there. All right. So the other thing which I want to include in the analysis, is the following. Right. So since the normal force is not acting up, that means not acting north, it is acting in a northwest direction. That means it is going to balance with the W perpendicular. It is not going to balance with the weight, because it is not acting in a north direction. It is acting in a northwest direction. So it's going to balance with the W perpendicular, not W. So that means the normal force for block P, the normal force is going to be equal to the W perpendicular, which is equal to mass multiplied by the gravitational acceleration multiplied by here, where we at here, the cos of the angle alpha. So that means the normal force for block P is equal to the mass of block P multiplied by the gravitational acceleration multiplied by the cos of the angle, which is 30 degrees. Then what about the normal force of block Q? The very same applies, because it is going to balance with with the W perpendicular, not the W, right? So the normal force of block P is going to be equal to W perpendicular, which is equal to the mass of block Q multiplied by the gravitational acceleration multiplied by the cos of the angle, which is 30 degrees, right? The only thing that's going to differ between the normal force of the block P and the normal force of the block Q is the masses. So that is the only thing that's going to influence the normal force of both the blocks. It is the masses, because the gravitational acceleration is the same and the angles are the same. So the only thing that's going to cause the normal force of the block P and the normal force of the block Q to be different is the masses. So I hope that is clear. So now we have actually done our full analysis regarding this question. We can get into answering the questions now. Right. So the first question says 2.1, state Newton's law in words. Okay. So 2.1 is asking us to state the Newton's laws in words. So Newton's law states that when a net force is applied to an object, by the way, this is the Newton's second law here. There's the Newton's second law. So we're going to just define what this is or what this means, right? So when a net force is applied to an object, the object is going to accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. Let me repeat that and then write it down. So we're going to be like, it is going to be long, so I'm going to need to speed up the video a little bit, okay? So when the net force is applied to an object, the object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the object mass, to the mass of the object. Yeah. So this is how we state the Newton's second law. Yo, it is so long. Anyway, let me shift my camera a little bit down so that you can see how we're going to answer the other questions. All right, so 2.2 says, draw a labeled free body diagram for block P. Fortunately enough for us, we have already done our analysis and we have noticed that this is how we're going to draw the free body diagram. So let us show them how to draw it. So we're going to have block P here represented by the dot, and then the normal force going in a northwest direction, and then we have the tension going or acting parallel to the incline, the tension force, and of course the weight acting down, or the gravitational force, and the frictional force. So the marker location is 4, and of course we have the 4 forces. The other people, they love to include the components as well. So you are welcome to include the components as well, like this, and show them that you are aware that there's components. And then say this is the W perpendicular and this is the W parallel. So you can either draw it like this, that means you include the weight, or the other people can actually draw it like this. When I say the other people, I mean the other learners. I know that they love to be referred by learners. The normal force acting in a northwest direction, and then the tension acting parallel to the incline, then and then the frictional force. Then instead of actually including the weight, they're going to include the components of the weight. So they're going to be like, okay, W perpendicular here, then W parallel here. So certain people have to draw it like this. So the W perpendicular and the W parallel are going to be considered 1 mark because they represent the same force, which is the W, which is the weight, right? So either way, you're still going to get 4 marks. So you can either draw it like this or like this. Right, let us go to 2.3. I don't know why I said 8. I think it is because I said the 8 marks. So 2.3 says, calculate the magnitude of the acceleration of block P while block P is moving on section AB. Okay, so they want the acceleration. Let me tell you something. Most of the times when they want the acceleration, you're going to have to utilize simultaneous equations. That means you're going to consider Newton's second law on block P and the Newton's second law on block Q. And then you're going to form 2 equations which you're going to have to solve simultaneously. That is why I said that you're going to have to consider simultaneous equations. So most of the time when they ask you for the tension or for acceleration, you're going to have to do simultaneous equations and then solve for acceleration and tension. All right, so I hope that is clear. So because I don't have enough space here, I'm going to do this in the next page, but I hope that you're going to keep note of the diagram that we have, especially the free body diagram. So let me actually go to the next page. All right, now that we're on the next page, let us try to calculate the acceleration of block P. Remember what I said, we're going to utilize the simultaneous equation. So 2.3, I don't know why I love to say 8 point something. Okay, 2.3, we're going to start with the F net, or the second law on block P, but please do not forget the free body diagram of Q. So free body diagram of Q is the following. So we have the Q, which is the block Q, and then the normal force, and then the force applied at an angle to the inclined surface. The inclined surface, and then we have the 25 degrees right there, and of course we have the Fx here acting to the right, and then Fy acting up, and then we have the weight, which also has its components, which are the perpendicular component of weight acting down and the parallel component of weight acting down the incline. And then of course I said, what did I say? The normal force. I said something about the normal force. I said that the normal force is equal to, I said the normal force is equal to W perpendicular, which is equal to the mass multiplied by the gravitational acceleration multiplied by the cos of the angle. So this is for P, this is for P, and then the Q is also the same, right? So just that for P, we're going to have to substitute the mass of the P, and then for Q, we're going to have to substitute the mass of Q, right? So we're going to have to note that the normal force is balancing the W perpendicular, which is equal to weight, which is mg, right, multiplied by the cos of the angle. So these two angles are different. So this angle is for the force applied. This angle 25 degrees, it is the theta. And then this 30 degrees is the angle of the weight, and it is 30 degrees, right? So now let us calculate the net force of, or apply the second law on block P. So we're going to be like the net force F net is equal to the mass multiplied by the acceleration, right? So the force that are acting on P, we're going to have to note the Fibonacci diagram of P as well. So we said that it is going to be the normal force, which is going to balance the W perpendicular, acting perpendicular, and then we're going to have the weight, of course, and then the W parallel acting to the down the incline, and then of course we're going to have the frictional force, then the tension. Oh, I forgot the tension when it comes to the block Q. I forgot the tension. We also have the tension when it comes to block Q. Okay, we also have the tension. I forgot to do that in the previous page, but now I've noticed that, oh well, I've realized that we also have the tension. Right, so these are the free body diagrams of P and Q respectively. This one is for Q. Right, so let us start with the P. So with the P, there's three forces that are acting parallel to the incline, and they are the frictional force, the W parallel, and the T, which is the tension. So because they said the block P is going from A to B, they didn't say from B to A. They said from A to B. That means it is going up. So the fact that it's going up, it means that the forces that are pulling it up are the ones that are greater than the ones that are pulling it down. So that means the tension force is greater than the sum of the two frictional force and the weight parallel. So we're going to have to write it first. So we're going to be like tension plus, so we're going to take tension as positive and the ones that are acting in the opposite direction as negative. So that means frictional force and the weight parallel is going to be negative. So we're going to like positive tension plus negative frictional force plus negative W parallel is equal to the mass of P, which is 2 kilograms. So 2 multiplied acceleration, which is the one that we're looking for, right? So we're going to like tension minus, because positive times negative is negative, minus the frictional force, minus because positive times negative is negative, W parallel, which we said it is equal to weight multiplied by the sine of the angle. But we also said that the weight is equal to the mass multiplied by the gravitational acceleration. So we might as well just substitute M multiplied by G, and then the cos of the angle is equal to 2A. Right? So this that you see here, we've taken it from the weight multiplied by the sine of the angle. Okay, I don't know why I said cos here. I was supposed to say sine. So I'm so sorry. Right, so this is where we're taking the W parallel from. So W parallel is weight multiplied by the sine of the angle. So weight is equal to mg. So whenever we see weight, we have substituted mg. So that is why you see the mg right there. Right, so we don't have the tension as well. So we're going to the tension minus. Remember that I said that the Fk is equal to 2.5 newtons. So we're going to substitute 2.5. And then minus the mass of P. The mass of P is 2. And then the gravitational acceleration is 9.8. It is a constant. And then the sine of the angle. So the sine, the angle of weight is 30 degrees. That 25 degrees only applies to the force applied. Okay, so we're going to substitute the sine of 30. So we have the sine of 30 is equal to 2A. So we're going to make T the subject of the formula. So we're going to be like tension, and then we're going to press the whole thing into the calculator to determine what it is equal to. So please allow me to press this into the calculator to determine what it is equal to. So after pressing that into the calculator, I get it to be equal to negative 12.3. I'm so sorry, negative 12.3, which is equal to 2A. Right, so we're going to make T the subject of the formula. So we're going to like T is equal to 2A, then of course plus, because when you take negative 12.3 to the right hand side, it becomes positive. So we're going to be like 2A plus 12.3. So this is going to be the first equation. So this is how we apply the Newton's second law on block P. Now let's apply the same law on block Q. So we're going to be like the net force is equal to mass multiplied by the acceleration of block Q. Remember that this is for block P. This is for block P. Now we're doing this for block Q. Right, so the forces, we're only going to consider the forces that are causing an effect on the motion of the whole system. That means we're only going to consider the forces that are acting parallel to the incline, which are, well, we have the Fx. We have the Fx acting parallel to the incline, not the force applied, because the force applied is at an angle. It is not acting parallel to the incline. So it is only the component, which is, what is it? What do I call this? The horizontal component of the force applied. It is only the horizontal force, the horizontal component of the force applied that is acting parallel to the incline, right? So we're only going to consider this force. And of course, we have the W parallel acting down to the incline, and of course the tension force, right? So the force that is going to cause an effect on the motion of this block is going to be the force X, or the horizontal component of the force applied. So we're going to consider it positive. So we're going to like that force X. Okay, let me shift a little bit to the right so that you can see. Okay, that force X, or the horizontal component of the force applied, plus negative of the two forces, which is the tension and the W parallel. So we're going to like minus tension plus minus W parallel is equal to the mass multiplied by the mass multiplied by the acceleration. So this, we know that it is equal to force applied multiplied by the cos of an angle, right? So we're going to be like, this is equal to the force applied multiplied by the cos of an angle. This angle, remember that I said this angle is different from that one. That is why I assigned them two different values. This one is alpha and this one is theta. So those are two different angles, like 30 and 25, right? So the force, the horizontal component of the force applied is equal to the force applied multiplied by the cos of an angle, then minus the tension, because positive times negative is negative, and then minus the W parallel, which I can just say it is mg. So I can just say it is mg sine of alpha. Why mg sine of alpha? Because W parallel is equal to W multiplied by the sine of alpha. So we know that W is equal to mg. So whenever we see W, we can actually substitute mg. So we're going to like mg, then the sine of alpha, right? So this is going to be equal to, the mass of Q is 3 kilograms, so 3A. So now we can actually substitute the values that we have. So the force applied is 40 newtons. So we just want to substitute that. So we're going to like 40 newtons, then cos of an angle. So cos of the angle which the force applied is acting at. So cos of 25 degrees, then minus the tension, which is what we're looking for. So we don't have the tension, then minus the m, which is the mass. So the mass is 3, then the gravitational acceleration is 9.8, and then the sine of the alpha. Not the sine of 25, the sine of 30 degrees, because it is only the force applied that is acting at 25 degrees. The weight is acting at 30 degrees, not at 25, right? So we're going to substitute 30 degrees, then this is equal to 3A. So we're going to make t the subject of the formula. So what I'm going to do is I'm going to write negative t, and then I'm going to substitute the whole thing into the calculator and check what it is equal to. So I'm going to be like 40 cos of 25 degrees minus 3 times 9.8, then sine of 30, and determine what that is equal to. So let me just press it into the calculator to determine what it is equal to. So after pressing into the calculator, I get the whole thing to be equal to positive or plus 24.95. I get it to be equal to 24.95. That is going to be equal to 3A. So because I want to make t the sum of the formula, I'm going to take it to the right hand side. So I'm going to leave 24.95 on the left hand side. So when 3A comes to the left hand side, it comes negative. So we're going to have negative 3A, then plus 24.95 is equal to tension. Now this is going to be the second equation. Remember that this was the first equation, and this one is the second equation. So this is how we do the simultaneous equations. Now that we have the two equations, remember that this tension, the tension which P experiences due to Q, is the same as the tension that Q experiences due to P. So it is the same force, but just that it is acting in opposite direction. So that is Newton's third law. So that means this tension here experienced by Q is the same as the tension experienced by P, just that they're acting in opposite directions. That is why we have negative acceleration here and we have a positive acceleration right there. So we're going to equate these two because they're the same force, just that they're acting in opposite directions. So we're going to be like, this tension is equal to this tension. So if this is tension 1 and this is tension 2, we're going to be like tension 1 is equal to tension 2. So since I actually have some space here, I'm gonna write it here. Not really. Actually, let me write it here. Let me shift my camera a little bit down so I can be able to see how we're going to calculate this. Alright, so now let's go. We're going to be like T1 is equal to T2 because they're the same force. So this is Newton's third law. Newton's third law. So T1 is 2A plus 12.3. T2 is negative 3A plus 24.95. So we're going to take negative 3A to the left hand side and it's going to become positive. So we're going to have 2A plus 3A, which is simply 5A, which is equal to 24.95. So when you take positive 12.3 to the right hand side, it becomes negative. So we're going to be at 24.95 minus 12.3. Let me put it into the calculator and determine what it is equal to. So the calculator gives me 12.65. Right, and then we're going to divide both sides by 5. And then acceleration is going to be equal to 12.65 divided by 5. Let me put that into the calculator and determine what it is equal to. So after putting it into the calculator, I get 2.53. Then this is meters per second squared. So this is the acceleration of the system. But they said the acceleration of block P. So the block P and block Q are going to move at the same acceleration because they are the same system. They are connected by a light inextensible string. So the acceleration of block P is going to be the same as the acceleration of block Q. So this is the acceleration of block P, and this is how we answer this question and get 8 marks. Right, so I hope that I've enjoyed how I've actually explained this and how we, you have also noticed how we tackle this type of question, how we approach it, and how we do the calculations. Right, so let us go to the last question for the video, which is 2.4. So 2.4 says, let me write it down here. So 2.4 says, if block P has now passed point B, how will its acceleration compare to that calculated in 2.3? Choose from greater than, smaller than, or equal to, and give a reason for your answer. So remember that block P is going to move from A to B, which is rough. So it is going to experience frictional force, which is going to limit or resist or deny its motion, right? But after it has passed point B, it is going to be moving on a frictionless surface, right? So that means now it's going to experience more acceleration because there's not going to be any force that is going to be pulling it down. Remember that this is the free body diagram of block P. So once it passes point B, it is no longer going to have the frictional force. It's not going to have the frictional force. So that means the only force that is going to be pulling it down is going to be the W parallel, which is the parallel component of the weight, right? So now that we have actually reduced or decreased the force that are going to be pulling it down, that means there's going to be a crater effect or the crater force that's going to be pulling it up. Therefore, it's going to accelerate because as we increase the net force pulling it up, then it's going to accelerate. That means its acceleration is going to increase. I'm so sorry. So its acceleration is going to increase because the net force pulling it up is going to increase due to the frictional force being eliminated. Therefore, the number of force that are going to be pulling it down is going to decrease because there's only going to be the weight parallel that's going to be pulling it down after cancelling the frictional force. So I hope that you actually understood how I've approached the question. So we're going to be like the acceleration is going to increase, or well, we're going to be like greater than. So the acceleration is going to be greater than before. Why? Because the net force is going to increase. Because the net force is going to increase. Remember that we are usually applying the second law here. So the second law says that acceleration is directly proportional to the net force. So if the net force increases, then the acceleration is going to be increasing. Therefore, it's going to be greater than before. So the fact that we're saying it is greater than, the reason is going to be because the net force has increased. So the net force pulling, the net force, by the way, it is the tension. So the net force, which is the tension pulling it upwards, will increase. So as the net force increases, of course, the acceleration is also going to increase because they are directly proportional. Or you can also just say the net force is directly proportional to acceleration. So these two are directly proportional. Therefore, the fact that the net force is going to increase, that means the acceleration is also going to increase. So this is the end of this video. The next video is going to be on question 3, which is going to be vertical projectile motion. So I hope that you've actually enjoyed the video and have understood how we tackle this type of questions. See you in the next video. Thank you.